Greetings and salutations. Thank you for clicking on the video. Today I'm going to talk about a couple of things that I always do every time I install a Linux system, and that is adjust the swappiness and activate write caching on the hard drives. Yes, I have covered these in videos before, but they were usually parts of much longer videos, and I've actually had a lot of folks ask about it. Also, I had somebody ask me a question that I'm going to demonstrate at the end of this video, so stick around for that little bonus feature there. And yes, we are back on Linux Mint 17.3. This is not Linux Mint Debian Edition, and I will tell you why at the end of the video, for those who care about such things. First of all, let's talk a bit about swappiness and why it needs to be adjusted and why you might want to fool with it in the first place. Swappiness describes the behavior of the system in how it uses the swap partition that is created on the drive when you install your Linux system. The standard setting is 60, and it pretty much means that it's going to start swapping out when 40% of the physical memory on the computer is used. Now, there's a lot more that goes into swappiness than just the percentage of memory used, but that's a kind of a convenient way to think about it. So if you set your swappiness down to something like 10, that means that the system is going to use 90% of the memory before it thinks about swapping memory pages out to the swap partition on the drive. If you would set it, on the other hand, to something like 90, that means that it would start swapping almost immediately when the system boots up. And for whatever reason, most Linux distributions, especially Debian, Ubuntu, and anything based on Ubuntu like Linux Mint or whatever, they ship with a swappiness set at around 60. And that's a bit too high for a desktop. It might be good for a server, but it's not so great for a desktop. And if you start opening up some big applications, like maybe you got a couple of web browsers open or you're playing some games, you might notice the system is slowing down, and that's because it's doing a lot of swapping. And if you are using solid-state hard drives and you have to put a swap partition on that drive, you will want to restrict the swappiness of the system as much as possible, because swapping to the hard drive involves a lot of read-write cycles, and SSDs don't like to be written to all the time. It will actually burn out the SSD if you do too much of that, and so therefore we kind of like to keep an eye on that. Now, I've been running SSDs for a long time, and I've never run into anything like that where the SSD gets burned up because it gets written to too much, but that's what people think, and that's one of the reasons why you would want to adjust your swappiness. So let's get into looking at that right now. And I have a virtual machine set up. This is Linux Mint 18 Mate edition. And we are going to be doing this on that machine because the host machine here has already had all of this done. So the first thing that we want to do is to figure out how we can see what the swappiness is. A little screen tearing there. There's a couple of ways to do that. So if you just don't know what it is, I mean, this isn't a freshly installed system. You can't remember whether you set it or whether you did anything with it. You can use this command to check your swappiness, and it will echo that the swappiness here is 60. There's another way to check that. If that doesn't work on your particular distribution of Linux for whatever reason, you can just get it straight from the horse's mouth, and you can look for the setting in the proc directory where all of the processes are. So we'll copy that, and then we'll go back over here and we're going to run that too. And it echoes 60. So you know that the swappiness on this machine is set to 60. You can use some commands to set the swappiness dynamically. I'm not going to go into showing you how to do that here. I'm going to show you how to set it so that the next time the computer boots up, the swappiness will be set, and then you won't have to worry about it anymore, because every time the machine boots up, it will set to your preferred swappiness. So, to set the swappiness, we need to get to a file that's called sysctl.conf. So this is the command that you'll want to use. And we'll paste that in. It's going to ask for my password. All right, and then you'll want to scroll down, or actually use your arrow key to go all the way down to the bottom of the file here, because we're going to add a line to this file. And the line that we're going to add is vm.swappiness space equals space 10. 10 is a good setting for the average desktop. That will keep the swappiness way down. It will not eliminate it. Some programs on your system use the swap file independently of the Linux kernel. So that is why I always say don't ever create a system without swap space, because some programs are looking for it. So you may notice that your swappiness is reduced if this is something that you're going to check up on. But it's not going to go completely away, and that's fine because we know that's the deal. So let's go ahead and add this line. I'm just going to paste all this in. Makes it a lot easier than typing. And now we want to save this by hitting Control-O and just enter to confirm that we want to save it to the same file name. We've written that file. We're now done. So we can go ahead and get out of Control-X. No, I don't want to save that. Okay. All right, I started to type exit. So now the swappiness is set, and the next time this computer boots up, it will be at 10. Okay, so before we move on from swappiness, let's talk about swappiness settings and what they do. Like I said, 10 roughly translates to the system will have to use 90% of the memory before it starts really swapping. Good for desktops, good for any system that has more than 1 gigabyte of memory in it, okay? Not so great for servers. Maybe on a server you actually would like a higher swappiness. It's a different kind of workload. So you may want to leave it at the default, or you actually might want to increase it depending on what you're going to do. In that case, you should do some benchmarking to try and figure out what's going on here, okay? And if you have a system that has a very, very low memory, we're talking like 1 gigabyte or less, then you may want to set the swappiness even lower to like something like 1, which would almost completely turn it off. Our virtual machine has 1 gigabyte of memory assigned to it, and so I'm just going to leave it at 10, but if I really wanted to tweak that up, I might set it even lower. Setting it to 0 will not turn it off, but it will really reduce the swappiness of the system. You do want a little bit in there so that it has some room to play with, just in case an application goes crazy and starts sucking up a bunch of memory. Just to keep the system going, you want it to be able to have some place to put all that stuff. Also, a note on swap for really low resource machines. If you have like 512 megabytes of memory, the machine is going to swap regardless. Doesn't make any difference. And you may want to increase the size of that swap file. Usually the swap file is just a little bit larger than the memory you have installed in the machine. Of course, I'm talking about a swap partition. You can also put swap in a file. If you have a small swap partition, there are ways to increase that by adding a swap file to the system, none of which I'm going to get into in this video. That's something that you would do in a special use case. But anyway, if you have a very low resource system you're trying to get running, and let's say it has under 1 gigabyte of memory, you're going to want to make a bigger swap file than usual, maybe like 2.5 gigabytes, something like that, and set the swappiness quite low, like 1 or 5 or something like that. And the reason why you're giving it all that space is just in case something goes crazy and starts sucking up a lot of memory. The system may slow way down, but it won't stop. And you don't want it to stop because you want to be able to fix the problem or close the offending application and then get back to life as usual. So there you go. Everything you need to know about swappiness and probably more. So the next thing that I always check is write caching. And this can be done from the command line, but it gets kind of complicated because it depends on what level you're doing it. The easiest way to ensure that write caching is working on your computer is to use a program called Disks. And it's part of the GNOME suite of desktop utilities, and it pretty much comes installed on just about every Linux distribution that's based on Debian or Ubuntu, and most other distributions have it as well. It's on Fedora, it's on Manjaro, it's on Arch, pretty much everywhere I've looked. But if for some reason you can't find it, the name of the package is the Gnome Disk-utility, and the command to start it from a terminal is gnome disks, and in the menu it's called disks. So what we're going to do is jump back over to our virtual machine, and we're going to fire off that utility. Well, I'm glad the connection was established. I never knew it was lost. Gotta love Linux. Okay, so gnome disks is the command, and we fire off the application, and it looks like this. And this is a very useful utility. It does a lot of different things. It's nice for working with USB sticks, checking the integrity of hard drives, all kinds of things. But today we're just going to concern ourselves with this one setting. And you go to disk settings, this menu right here, and then you go to drive settings, and then you will get this dialog right here. And the one that we're concerned with is write cache. And at this point it is turned off. Now we want the write cache turned on, and it's going to ask for a password to do that. Depending on what desktop you have, this little menu up here moves around. I'll show you what I'm talking about. In this incarnation, which is one of the later ones, you'll see that it's part of the client-side decorations up here. And if we just get off this desktop and go back to our Linux Mint 17.3 desktop, I'm going to open up disks, and you will see that now that menu is here, but it has exactly the same things. And feel free to play with it. You can't break anything, and if you do, it's your system anyway, so you can reload it if you want to. Now, what exactly did we just do? That's probably the question that you're asking yourself. Okay, Linux, or at least Ubuntu-based Linux, most Linux that I've looked at, ships with the write cache turned off. Your hard drive has a little bit of volatile memory in it, sometimes as much as 8 megabytes on some older drives. It could be up to 16, 32. I don't know what it is now. I haven't looked in a long time. And what that does is if you send some data to the disk to be written, it is stored in this temporary memory just for a second or two, and then when the disk is idle, it gets written. And that's pretty much on by default, and it works in the hard drive itself. The write cache that we just enabled is actually in the Linux system. So Linux takes the safe route, and it says anytime that something has to be written to the disk, it's going to stop doing everything else, and then it's going to write that file to the disk. And yes, this is the safest way to go because there's very little risk of data loss, because as soon as the command goes out to write the data, it gets written, and if the computer for some reason should lose power or crash or something like that, then you won't lose that data. Great. The only problem is that since that write priority is set in the system, every time it goes to write, it turns off everything else in the system while it's writing that. So if it wants to read and write simultaneously, then write first, then read. Write first, then read. So if you open a big application like a web browser, or you open a game, or something big, a lot of times these applications, they read and write simultaneously when they start up. They're writing things like creating temporary files, log files, stuff like that. And so all of that write operation having to go first before it's read will slow everything down. If you tell the system, hey, it's okay to hang on to that information for just a little bit that you want to write, then it doesn't have to stop reading while it's writing, because it just takes the stuff it's going to write and sticks it over in memory here, and then it just keeps on reading. Makes the application boot a lot faster. So that is one of the pluses to doing that. Also, if you want more efficient use of an SSD, for instance, then when it does go to write, it writes it all in one big block. It's not write a little bit, no, that was wrong, rewrite that, no, that was wrong. No, if it's doing it in a cache, then it's kind of hanging on to all that information, and when the system slows down a little bit, it's got it all set, and it says, okay, this is what we want to write, boom, then it goes to the SSD in one write cycle. Bam, there it is, it's done. So it will actually help your SSDs to last longer. The downside of doing this is that, yes, there is the chance that if the system locks up or the system loses power and there's a lot of stuff sitting in the write cache, that it'll just go poof, and that could corrupt a file, cause a problem here and there. My experience with this is that it generally doesn't happen that way. I've not run into any major problems. I've never had a system get trashed because write cache was on. May have lost a file that I was working on in a word processor or something like that, but nothing major that couldn't be recovered. So for me, the benefit far outweighs the risk. Plus, if you're running anything on a laptop that has a battery in it, it's kind of hard to make the power go completely away on a laptop, but there's always the chance of data corruption anyway, whether this is on or not. So unless you are really, really paranoid about losing data, then you may want to leave this off and just deal with a slower system. So that is what that is all about. And once you have these settings set, you're probably going to want to restart the computer so that they will take effect. So instead of just restarting it from the menu here or restarting it from the terminal here, I'm going to show you something that somebody asked me about the other day because I had mentioned it in a past video, and that is they asked, how do you power off another machine remotely? So I told them you do it through SSH. It's the easiest way to do it in Linux, that's for sure. So I'm going to do it that way just to show you how it works. Okay, so I'm going to open up a terminal here on my main desktop. And now we are going to SSH into the machine that we have running in a virtual machine. Didn't think that was going to work. Put in the wrong IP address. I just forgot what the IP was for that machine, but I got it now. So let's go back and put it in as 21. Now we're in. Okay, I don't know, it changed the IP address. I must have rebooted it since I set it up. It's dynamic IP. You have to check it in the virtual machines because I'm using a bridged adapter. Anyway, we're in the machine. It doesn't matter. And once we're here, we can go ahead and clear this screen. Okay, and now all we want to do is to turn that machine off. So what I'm going to do is I'm going to issue the power off command. And it'll ask for my password. And now we can watch this machine turn itself off. And there it goes. So yeah, that's how you do it, gang. Alright, so that machine is gone now. So yeah, I just wanted to show you how that worked in SSH. I did a whole video on SSH and a bunch of stuff about that, but no big deal. And you see it tells me that it was closed by the host. Okay, so now that we're done with the main content of the video, for those of you who have been following my videos for a while, yes, I am back on Linux Mint 17.3. This is not Linux Mint Debian. By the way, those notes will be posted in the description for this video. And just to show you, we're running 17.3, and we are on Cinnamon version 2.8, and I've got kernel version 4.2 dash 4.2 generic installed here. Now, why am I not on the 4.4 kernel, you may be asking? I'm not on the 4.4 kernel because it actually breaks something with this system, and it causes a problem at login where the login screen is like huge, and that's because I'm running dual monitors on this system. And so therefore, if I hang back and stay with 4.2, then it renders properly and I can actually log in and log out and use the grub menu and stuff like that. So anyway, that's why I'm on 4.2. I'm a little bit more comfortable with having 4.2 running with Linux Mint 17.3 than 4.4. That's current because that's the current kernel for Ubuntu 14.04, which is still supported. So I'm going to stay with their kernel. And it's the same machine that you saw before. And the main reason that I actually changed this up was that somewhere along the way, I lost the ability to suspend the system with Linux Mint Debian. Don't ask me how, because I don't know. But as you can see here, I can suspend, hibernate, I can restart, I can cancel, I can shut down. I wasn't getting any of those. All I could do was cancel, shut down, and restart, and the automatic suspend wouldn't work. And in this particular use case, that is something that I absolutely positively have to be able to do, is suspend the system. I like my computers to go to sleep after a little while when I walk away from them, and then I can tap the power cut button or a key on the keyboard to wake up. But unfortunately, with Linux Mint Debian, that went away. So we went back to Linux Mint 17.3. That's how that happened. Not that I have anything against Linux Mint Debian. It just had a little conflict with this hardware, and this is the machine that I need it to run on. So 17.3 again, it works. Somebody asked me if I bothered to do like remaster sys or use any of them really fancy backup programs when I reload a computer. I don't, actually, at all. I just back up all the data onto another hard drive or something like that, and then reload the system. It takes all it takes is transfer data time, and whether you have a clone of it or whether you have it transferring the data, it's pretty much the same. And installing Linux, for me, I can do it in my sleep, so that's how I take care of that. And there was one thing that I did change here, because I wanted to get a little bit more efficient use of the drive. So I'll show you the file system table file here for this computer. We have swap. Swap is actually up front on the drive. It's the first partition, although it's not being showed in that order here on the FS tab file. And then we have the boot partition here. So yeah, see, it's on SDA2, and SDA1 is swap. That way, if I want to take this drive out and expand it, I can at some point clone it and then put a bigger drive in, which is something that I probably am going to want to do somewhere in the not too distant future, because if we go to DF, I can show you that this drive, just bring that up a little bit, the partition is like 70% full already, and that includes virtual machines. I only have 2 of them, so it's a 320 gigabyte drive. It was a drive that came with the computer I bought not too long ago, so when I was rebuilding this computer, I just tossed it in there. And it's a little spinning drive, so it's a little bit slow. So at some point, I'm probably going to want to upgrade this, and I'll use something like Clonezilla to move that over. And so that's why I set those partitions up. If you have a separate home and root partition, that's great. The only problem is that the unused space on the root partition cannot be claimed by home, so therefore it's less efficient. And since this drive is mostly full, that's why I decided to do that. But anyway, the last 5 minutes of this video were for those of you who really give a damn, you know what I mean? Thank you for watching. I hope this helps you out. A lot of people have been asking about it lately. Do check out freedompenguin.com for lots of great articles about Linux from contributors like myself. And also check out Easy Linux on the web, check out Easy Linux on Facebook, and give it a like if you would, please. Talk to you again soon. Thanks for watching.